here. Jide asked me to come give a talk, and I said, that'd be great. And then I looked at the list of presenters, and I thought, with my luck, I'll probably get slotted immediately after Angus Deaton, and here we are. So I hope you'll humor me anyways. So I'm going to talk about the way that econometrics textbooks have historically dealt with with concepts of causality. So basically, I took a whole bunch of textbooks. I have infinity plus 2 textbooks because I have 32. And I read them and I tried to figure out what they were saying about causality, and in particular, if they said anything at all about causality, and if they did, what were they saying? So, and how has that changed over time? So I'm going to try to convince you that econometrics textbooks haven't done a good job of explicitly talking about causality, but maybe they've done a somewhat better job of implicitly talking about causality, and they're recently anyways getting better in this dimension. Okay, so what's the context? Well, the context is, well, first of all, there's a hole in the literature. So there is a fairly large literature in the history of economic thought on the development of econometric ideas, but there's practically nothing on the way that econometrics has been taught historically. And there's also been these critiques of the way that econometrics has dealt with causality from Bryant Chen and Judea, and this recent paper, which is the motivation for this section of the conference by Angus and Pischke, in which they claim that the way that we teach econometrics is outdated, essentially. So we have this momentum from the 70s that I'll talk about a little bit later, and they claim we don't do econometrics the way that we used to, so we should change the way we teach econometrics. Okay, so just to fix ideas, part of what I want to look at is do textbooks get across simple ideas of causality, even if they don't explicitly use that word causality? So if we think about this model that we've seen several times today already, and we've all seen ad nauseum, if y is beta x plus u, just writing that equation doesn't mean anything at all. We have to start defining terms before we can even say what this equation means. If, for example, we define the error term u as being the difference between y and its conditional mean, then it's true by definition that the error term is uncorrelated with the regressor x, and then we get, well, all sorts of nice properties, but we also can't treat the coefficient beta as causal. So if, on the other hand, we say that this is a structural model, that what we mean here is that y is caused totally by x and by u, then we lose this property that it's that u is independent of x, and if we well, if we run a regression of y on x, the coefficient doesn't necessarily give us a causal effect, and with economic data in particular, it generally doesn't give us a causal effect. So I read these textbooks mostly in thinking about, would a student understand these basic issues after reading the exposition of this model in the textbook, and looked at a few other things as well. So I think most people here are probably economists and have endured an econometrics course, but just in case you haven't, it's useful to phrase this in terms of, or place this in terms, have some context here for what's going on in econometrics textbooks. It certainly wouldn't be reasonable to expect textbooks to be discussing something which hasn't yet been invented in the literature. So we might say this goes back to the end of the 17th century when the first statistical demand curve was published. Then there's a slight break up until just before the Second World War when people really started seriously thinking about the problem. Well, if I write down a scatter plot of prices against quantities and draw a regression line through them, what exactly is it that I'm estimating? So the landmark papers are Havelmo during the Second World War, 1943 and 1944. Jim Heckman has described this as the first formalization of the concept that correlation doesn't imply causation. So he develops simultaneous equations and the concept of simultaneity bias. That leads into the work of the Cowles Commission in the late 1940s and early 1950s, when all of these ideas are extended and formalized in great detail. This basically consists of taking a bunch of variables, splitting them up in a somewhat vague way into the so-called exogenous variables and the endogenous variables, and writing down a big system of usually linear stochastic equations describing the endogenous outcomes. We then have some causal concepts introduced, in particular Granger's so-called causality in 1969. This, I am going to argue, just confuses things because Granger causality is not a causal concept at all. So one of the things I'm going to show you in the textbooks is, if they talk about causality, do they just say that causality is Granger causality? We have Lucas's critique in the 1970s, so he gets us to think about what's invariant and what's not in a way that we hadn't before. We start to see the introduction of the potential outcomes framework in the mid-1980s with Heckman and Rob's work. This is extended by Emmons and Angrist in the early 1990s. Around the same time, say during the 1990s, we start to get an emphasis in econometrics on using natural experiments and methods which make our econometric results mimic controlled experiments more closely, such as regression discontinuity designs. Okay, I think I'll just skip that slide. So one thing I forgot to mention earlier was there is a little bit of work on the history of econometrics textbooks by an economic historian named Quinn, I guess that's how you pronounce her name. And one of the things she talks about is what she claims is a standardization of textbooks during the 1960s. So in her phrasing, econometrics textbooks become regression handbooks. So if you haven't had to learn out of one of these textbooks, if you pick up a random one, you're probably going to find something that looks more or less like the outline I've got in this slide. Oops, not on that slide. Where did my slide go? This slide. So you start with a standard regression model, and of course it's usually going to be multivariate, but let's just skip those things here. And you say, well, what happens if U and X are independent, and you prove that the ordinary least squares estimator has many desirable properties in that case? Then you say, well, okay, let's continue to assume that U and X are uncorrelated, but maybe the error term has lots of nasty bad qualities, like it's serially correlated and it's heteroscedastic and so forth. And then you work through a chapter on each one of these problems, and you say that generalized least squares is going to solve these problems. Then you get to the discussion of instrumental variables and simultaneous equations models by adding another equation. And then you have sort of a random scatter shot of other issues you may or may not discuss towards the end of the book, such as unit roots and cointegration and Bayesian issues and limited dependent variables. And depending on which textbook you pick up, you might find a different selection of those sort of optional topics. Okay, I don't have much time, actually. How much time do I have?
You haven't until C30.
Oh, I didn't start at 2, though, did I?
Okay, you have 2 until 2:35.
Okay.
Or no, you're right. It'd be more like 2:40, right?
Okay.
Yeah, sorry.
Okay, so I've got this, this sample of size infinity plus 2 on econometrics textbooks, and I'm going to read through them and try to figure out what's going on. So I'm going to figure out how many pages are devoted to what I am going to term causal methods. So here I mean methods that are almost exclusively used to try to uncover causal relationships. So by this I mean instrumental variables, simultaneous equations model, panel data methods, since they're usually but not always devoted to looking for some sort of causal effect. And of course, if there's an explicit discussion of what are explicitly causal methods, such as treatment effects models, I'm going to count those as causal pages. More simply, I'm going to look to see whether there's any explicit discussion of causality at all. So does the book even use the word causal? And does it, if it uses the word causal, is it only referring to Granger causality, or does it have something else in mind? And I'm going to try to be really generous to these books here. Even if there's just one sentence that says, student, you shouldn't interpret correlation as causation, I'm going to count that as a discussion of causality. I then want to see how is beta defined? Is there a discussion of what it means? And if there is such a discussion, is it a misleading or outright incorrect discussion? And the same thing with the error term. So I'll talk a bit more about what I mean by that in a second. And this is following Judea and Bryant's paper, where they specifically criticize econometrics textbooks for making a mess of these issues. And then for reasons I'll get to at the end of the talk, I also want to look to see whether they use supply and demand as a motivating example, or use trying to estimate Keynesian marginal propensities to consume as a motivating example. Looking through these textbooks is often a little bit difficult because I think causality is maybe the most commonly misspelled word in the entire canon. Okay, so what do I mean by a problematic definition of beta or a problematic definition of the error term? Well, suppose I write down the conditional expectation of y given x If I define beta as the gradient of that object, I'm going to say that's a problematic definition of beta because it's generally not. Generally, we want to hold other things equal, and we're not and the only thing we're holding equal here is x, so we're going to screw up our discussion of causality, or we're at least going to confuse students about our discussion of causality if we make this by definition true. And at the moment, I'm saying a different problem, although really I suppose we could say they're kind of the same problem. If I define the error term, again, as the difference between the outcome y and its conditional expectation, I'm essentially just assuming away all of the issues we have to worry about as economists and other scientists who deal commonly with observational data. So I'm going to say that's problematic as well. I'm again trying to be generous to textbooks here, so I'm not going to include books which first say, and this is quite common, here's assumptions A1, A2, A3, A4, and A5, and under these assumptions, it is the case that that's valid. It may be misleading to students in some senses, but it's not actually erroneous or problematic in the sense I mean. So I mean a more fundamental issue than this. So to give you some examples of what I'm defining as a problematic discussion of beta or the error term, here's a, let's see, do I have a, this is a thing? So here, of course, is a definition of beta as being the gradient of the conditional expectation of y given x, which is problematic. This book doesn't first say, let's assume that u and x are independent. It just gives this first as a definition and then talks about those assumptions and the statistical properties of the OLS estimator. And if you look down here, it makes the problem worse by saying, so y here is consumption and x is income in the example they're giving. And they talk about how economic theory tells us about what this conditional expectation function should tell us. And that is just wrong. What economic theory tells us about is holding all other things equal. If we exogenously vary income, how would we expect consumption to change? We are not holding all else equal in this little conditional expectation function, so this is problematic and I would think confusing to most students. This is the most egregious passage I found in all the econometrics textbooks I read. It's box 1.1. It's set off from the rest of the text to emphasize to students that they should really pay attention to what's going on in this argument. And they start off by saying that a foolproof way of interpreting, here they've got OLS estimates, not betas, but essentially the same thing, or worse even. If you run an OLS regression of y on x, how do you interpret this coefficient beta 2? Well, the first step, they say, is to say that a 1 unit increase in x, measured in units of x, will cause a B2 unit increase in y, measured in units of y. And then having established causality, what you do is just look to see what units you're actually measuring things in so you can phrase your result. So, no, I mean, this is just, I can't even imagine being an undergraduate, well, I guess I can since I was, but that is certainly going to confuse any undergraduate student. And if one of my undergraduates tells me that that's how you interpret an OLS coefficient, they're going to get an F on their first semester econometrics midterm. So similarly, here's an example of a textbook which is incorrectly defining the error term as the difference between the outcome and its conditional expectation. So this is quite common, and again, I'm going to count this as being problematic. So here's some summary statistics. We'll just highlight a few things, and I'll show you some pictures, which are probably easier to figure out than just a big wall of numbers. So just highlighting a few things here, 43% of the textbooks I looked at have any discussion of causality whatsoever, so the majority of books just completely ignore this issue. The ones that do discuss causality almost never actually define what they mean by the word causal. They just sort of take it for granted that students know what the word means. So 15%, so what is that, like 8 or 9 or less than that? Like 4 or 5 of the textbooks actually explicitly say what they mean by the word causal. The proportion of pages on methods which I define, or I'm going to interpret anyways, as being explicitly about causal analysis is very low. A substantial portion of books only talk about Granger causality and might lead students to believe that that is what we think causality is in econometrics. And a pretty substantial proportion of books incorrectly defines either beta or the error term or both. So Now, so just to give you an idea what the sample looks like, this is just the distribution of years of textbooks. So I'm going to talk a lot about what's going on in the 50s and 60s, and you should keep in mind to treat that with a bit of a grain of salt, because I only have a handful of textbooks that are that old. This is preliminary. I want to get a few more books so that I have many more than infinity for my sample. On the other hand, this is a bit misleading because I'm using often later editions of books, and what I've got here is the year of publication for the edition I'm looking at. So a lot of the books that have apparent publication dates in the 70s, 80s, or even 90s actually have first editions going back deep into the 1960s, and they tend not to change very much. So keep that in mind as well. So I'm going to show you some little pictures like this to show what's going on in these textbooks. These are just predicted values from either OLS or probit regressions. And yes, you can interpret the coefficients as causal in this context. So first of all, textbooks, let's see, just all the slides are going to start from 1950 and go up to 2020, just giving predicted values, again, to summarize loosely what's going on. And I've got 95% confidence intervals there, and you can take those with whatever credence you deem appropriate for this sample of size 32 and mostly nonlinear models. So textbooks got a lot longer between about 1950 when I start looking at them until the 1980s, and then they start getting shorter again. And that's going to be a kind of common theme. Things are going to get really bad, I'm going to argue, in the 1980s. So if you consider long econometrics textbooks bad, that's what's going on here. The proportion of, or the absolute number of pages devoted to one of these so-called causal methods goes up over time, but since textbooks are getting much longer over time, the proportion of pages devoted to these causal methods is actually falling through to about the 1980s, and maybe you believe it's going up a little bit after that, but again, this is just predictions off a quadratic, so again, use your discretion in interpreting this. So this might be the key cartoon from my talk. If you just remember one thing, remember this. This is the, is there any discussion of causality whatsoever in the textbook? So what goes on is the really early textbooks from the 50s and 60s do tend to include discussions of causality. So this is over here, this is over half of the early textbooks talk about causality and warn students about not making causal interpretations. And then that falls quite rapidly up until the nadir here in the 1980s when a very small fraction of textbooks actually discusses causality. And then things start to get better. So during this century, textbooks do tend to, again, start discussing causality. I didn't discuss this. So one thing I also looked for was, did the textbook just say this is the error term and it's a random variable, or does the textbook include at least some discussion about how students should interpret what the error term means in these regression models? So this is there some discussion of what this means in various contexts? And you can see that, well, about half, I forget what the actual mean is, but about half of textbooks discuss this. And again, it starts off pretty high, falls, and then rises again. This is the same thing for, is there a discussion of what the slope coefficient on the covariate of interest means? And again, it starts off pretty good in the 1950s and 60s, then gets bad in the 80s, and then picks up again relatively recently. This one is, does the textbook only discuss causality in terms of Granger causality? So it's not fair to look at textbooks before 1969 because that's when that concept was invented. And then there's all these textbooks through the 70s and 80s and 90s which only discuss Granger causality. So if you read one of these books and thought that was the totality of economic or econometric thought, you would think that Granger causality is causality. Then, happily anyways, it starts getting better again, and none of the very recent textbooks, say in the last decade I looked at, discuss Granger causality as if it's the alpha and omega of causality in econometrics. So this is, do textbooks incorrectly define beta as being the gradient of the conditional expectation of y given x, and you can see, again, sort of the 1980s are really bad. Into the 1990s, I should mention, I was trained in econometrics right about here in the early 1990s. So I'm at the worst as a student for all of these things. And this is the error term defined incorrectly, and that's actually something that's gotten bad recently. So a lot of recent books incorrectly define the error term as this difference between y and its conditional mean. Okay, so just to give you a flavor of what's going on here, this is the earliest textbook I looked at. This is Klein, 1953, which is an amazing book. If I could still teach out of a 1953 textbook, I would use this textbook for my own econometrics classes. What it does, so chapter 1 is just sort of introductory blather, and then the book really starts in chapter 2, and what it says is, suppose we wanted to estimate a demand curve. Then it goes on for 50 pages to motivate all sorts of econometric methods and econometric problems using this particular example. How would we actually go about estimating a demand curve? So you can see on page 2 of the textbook there, they've already got a scatter plot, and they're getting students to think about what that scatter plot might mean. And by page, I've cut off the exact page number, but I think it's page 10, they're teaching the student about how to use an exogenous shock here, the weather, so this is rainfall, this little not particularly clear graph, but it's a surprisingly modern graph, is showing a supply curve sweeping out a demand curve, and the supply curve is being moved around by rainfall shocks. So they've already got the key insights from instrumental variable analysis by page 10 of this book, with hardly any mathematical content at this point. This is from Amemia, 1985. This is how students are being taught econometrics 30 years later. On page 1, we get consider a sequence of k random variables and blather, 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 hieroglyphics. We are concerned with inference about the parameter vector theta on the basis of the observed vectors y and x star. So we went from this, let's look at this real world problem and start thinking about how we might use data to actually get at this real world problem, to we are concerned with inference about this parameter vector. So again, I think the 1980s are really, something has changed in econometrics teaching, where by the 1980s, econometrics textbooks had become mathematical manuals void of any actual economic content. So nonetheless, I'm going to argue, I'm going to argue that nobody's really being confused here. I think even students such as myself, who were taught out of econometrics textbooks that look like this, were never really confused about whether whether correlation equals causation. So this is a bit of a puzzle because hardly any textbooks, as I've just showed you, actually discuss this issue, is correlation causation. So how can it be that I'm going to claim most economists aren't confused? They're not going to interpret correlations as causal if we're not teaching our young that correlation doesn't equal causation. So what I'm going to argue is econometricians want to avoid this. So they don't want to talk about causality. All they want to talk about is, I have some model, there's parameters in that model, I want to figure out a consistent way to estimate those parameters, and oh, if the economic theorist tells me that those parameters are supposed to have a causal interpretation, well, that's nice, but I don't care, I'm the econometrician, I just want to estimate some parameters. So one textbook, the textbook I was taught out of when I was an undergraduate actually, Commenta 1988, explicitly says econometricians as a rule avoid the concept of causality altogether. I asked a senior colleague of mine, actually the colleague who taught me out of this textbook, it turns out, in the mid-1980s or late 1980s, who also wrote a textbook about 20 years ago, and which doesn't include any discussion of causality. I went to his office and I said, I'm writing this paper about the history of econometrics textbooks. I looked at yours. Can you explain to me why you didn't discuss causality in your textbook? And he went, econometricians do not discuss causality. So that was news to me, and I think part of the reason is, as soon as you start discussing causality, fistfights break out. So if you go look at blogs, for example, as soon as anything causal comes up, we want to define causality, we want to think very philosophically about causality, people don't agree. So I think part of what's going on is simply that econometricians, or at least as econometrics as expressed in textbooks, wants to avoid this fistfight, and thus it becomes this abstract problem. Let's talk about estimating parameters rather than thinking about causality deeply. And again, the context here, or well, not again, but the context here is I don't think students are really confused about this, in part because we have to place the econometrics curriculum alongside the economic theory that's being taught to students at the same time. So you can't, or it's misleading anyways, to just lift the econometrics curriculum out of its context, all these theoretical notions which are about causality, and discuss it in isolation. And the example there I want to look at is the example we've seen before today, just supply and demand. So 80% of the econometrics textbooks I looked at use exactly this little model to talk about simultaneous equations bias or other forms of bias when we're trying to estimate a demand curve. If we think about, oops, sorry, I guess you can't see that. So here we've got the demand function, the supply function, an equilibrium relationship, and these gamma. So the slopes of the supply curves here are, in fact, causal parameters. They won't be defined that way in a microeconomic theory textbook, or, as I've just shown you, in econometrics textbooks, typically. But I don't think anyone's confused about this. What we mean by, say, gamma D, the slope of the demand curve, is what would if somebody were controlling price as if by a randomized controlled experiment, how would that affect consumers' quantity demanded? One textbook, in fact, Klein 1953, that example I showed you before with the extended discussion opening the book, explicitly says that. Suppose there's a monopolist who wants to learn about the demand curve. How would they do that? Well, they would undertake a controlled experiment, set prices at various levels, and then observe how quantity responds to those exogenously set prices. That gets lost, but this is what we have in mind, and even if textbooks don't discuss that, I don't think students are particularly confused about it. So that's what I just said. I'm running out of time. So here's some quotes from books that don't use the word causal, but do highlight to students that they should think about the econometrics in terms of microeconomic or macroeconomic theory. And again, those theories are actually causal theories. So Klein 1953 says, there's a problem that observed correlations between prices and quantities of commodities did not necessarily reveal the nature of the demand curve. So I would argue what he means by that is these correlations don't actually recover a causal effect. Davidson and McKinnon, which is a very abstract, very mathematical regression handbook, says on page 2 that as is true of a great many econometric models, the parameters of this little Keynesian system they're considering can be seen to have a direct interpretation in terms of economic theory. So again, if you look at the economic theory, it's essentially talking about a causal concept, and the authors here are highlighting to students that they should think about these econometric issues in the context of economic theory. So where are we then? Well, we have these econometrics textbooks which are treating consistent estimation of parameter estimates, and in the context of economic theory, we're really thinking about causal effects, but they mostly don't talk about causation at all. So I think there's costs and benefits to this way of teaching econometrics. And by statistical properties here, I mean the joint distribution of the observed and unobservable variables. When we define causality implicitly or explicitly as, say, well, I want my parameter estimate, say, beta tilde IV to converge to the true value beta, again, I think everybody is sort of on board here that what we really mean is, am I consistently estimating a causal effect? And we phrase that in terms of the joint distribution of these variables. When is this covariance between W and instrument and Y divided by the covariance between W and X going to converge to the true value? Incidentally, I would normally use Z as an instrument, not W, but I know that you guys will probably make fun of me if I correctly pronounce the letter Z. Okay, so the problem with this, though, is it can lead to sloppy thinking about causality. So we've got this very precise statements about the joint distribution of the variables. How does that map into our mental models, as Judea might say, of causal concepts? And I think here we're still making a bit of a mess of it because it's easy to fall into sloppy thinking about how causality relates to these statements about the joint distribution of the variables. So, for example, a phrase that I myself have used to my econometric students, now I realize to my chagrin, is an instrument is valid if the only reason why, or the instrument W causes Y only via its effect on X. So what we're saying here is if we have this little model where the W, the instrument, causes X, and in turn X causes Y. Oops, Sorry, I've actually screwed up the graph. So pretend the top blue line isn't there. So what we're saying is if the red line doesn't exist, this is a valid instrument. If there's no causal effect of W on Y, the only reason why W and Y should be correlated is because of the effect of W on Y via X, then W is valid. This is not correct, right? If the instrument and the outcome are confounded by a joint cause, then W is also invalid. But if we're thinking just in terms of the top, slightly incorrect, again, sorry, diagram, we might mess that up. And in fact, Margolis 2015 makes exactly this argument in a very extended case with respect to the Acemoglu Robinson paper about using settler mortality as an instrument for institutions. This is exactly the argument that he makes. Okay, so I think I'll skip that slide. So what did we maybe learn here? So I think hopefully I sort of convinced you that econometrics textbooks started off in the 1950s and 1960s doing a pretty good job telling students about causality. So they might not, obviously that's void of our current modern understanding of causality, but, and often without defining causality, but they at least highlighted explicitly to students when you calculate a correlation between variables, you shouldn't necessarily interpret it as causal. Then there's a decline in that. By the 1980s, textbooks become very mathematical and they avoid talking about causality altogether. And relatively recently, we've gotten better again about explicitly talking to students about causality. I guess that's it. Again, I think some of that might be a little misleading because, again, I'd argue we have to place these econometrics textbooks in the context of the broader economics curriculum. And I don't think anyone, even students, are confused about this notion, even if it's not in textbooks. Angus talked about fistfights in seminars about whether something's endogenous or not, which we've all encountered. Really what we mean there almost always is this a valid estimate of a causal effect? So maybe it would be better if we started using that terminology rather than continuing to use these sort of kind of causal notions, exogenous and endogenous. Thank you.